Okay.
So, hello guys. Welcome to the second virtual OWASP Dorset event. We're happy to have you in this sunny day, I would say, and very hot, I would say. So today we are very happy to have a colleague, Shruti Konkami. I hope I haven't butchered her surname. So do we have any news that we want to say, guys, before we start with Shruti? Or shall we jump straight to?
Just that we're looking forward to having an in-person meetup when we eventually get around to doing that.
Yeah. We are I'm actually waiting to go out and meet people.
Yeah.
Without any restrictions. Okay, so let's, without any further ado, let's add Shruti to the stream. Hi, Shruti.
Hi, everybody.
And Shruti, if you don't mind sharing your screen again, because it's not in the stream.
Okay, let me try again.
And I think if Dan and Mark agrees with this, we can disappear from the stream and we will let Shruti she will have the virtual floor to give us an exciting talk about container security.
Yes.
Yeah.
Thank you.
Okay.
Can I stop my video just so that it doesn't consume a lot of bandwidth?
Yeah, of course. If you want to show your only the screen while you are presenting, go for it. Okay.
Thank you. Thank you. Okay, so I don't see my camera. Let me bring up the presentation.
Mm-hmm.
Yeah.
So.
Can you all see my screen?
Yes, we can.
Okay, so without any further ado, let's dive into it. Okay, I'm going to talk about security of containers. So before we start off, let me introduce myself. I'm an enterprise security architect, and I have more than 12 years of experience in information security. I've worked a lot with ISO 27001 and PCI DSS, and I've also got a good level of experience with NIST and CIS frameworks. So I work with policies, processes, technologies, architecture, design, implementation, and maintenance of security systems. I've done a bit of certifications as well. Right, let's start off. So what are containers? Containers are virtualization of operating systems, which is a manner in which you isolate applications from one another within the context of the running operating system. So it's something similar to jail file system, and when configured to do so, the applications contained in a container cannot access components outside of it. And I stress on the word when configured to do so, and we'll see why in the coming slides. So as I mentioned that, it cannot access, it has an isolation. A container has an isolation boundary. So it also has a isolated network, stack, process space, and an instance of a file system. So any container shares the operating system with other containers that are running on the same host. Now, when we talk about containers running on the same host, there's nothing stopping anybody from installing two containers and then a web application or a web server along with it. I specifically mentioned this so that we can refer to it later on in the slides. So containers, like any other asset, need to be assured for security. So before we start off, I just want to put in a couple of caveats. This presentation is not oriented towards any technology or vendor. This is a technology agnostic presentation, and the principles that we are going to talk about in this session can be applied to any technology. Of course, the specifics will differ, but the principles will remain the same. So just a bit of a thing, like, why do we need containers? What for do we use? So we talked about isolation of containers with respect to other containers and operating system. So it's a good mechanism to do your malware analysis. And then though microservices is an architecture feature and containers are a technical feature, you can use containers to speed up your microservices and support the microservices that you may have for your system. Then there are some other things, because containers are consistent across wherever you run them. Like you can create a container on your laptop or on a server. It will still have the same kind of file system. So it's quicker to deploy into a hybrid cloud or a multi-cloud environment. That's another use of it. This just for information. Now, before we start looking at the security of containers, let's look at a bit of a background to it. So what is really a container? Now, Linux has certain features, which I believe came around the time frame of 2003, 4, 5. But Linux 2.4, I think, introduced a concept of namespaces. With these namespaces, you could actually create and you could isolate and manage resources in a manner that they ran like independent systems. So Linux introduced namespaces for managing resources using C groups, creating hierarchies of isolated subprocesses using PID namespaces, then separating out your network stack and managing a network. Is there any disturbance? Can you hear me clearly? Okay. So I've illustrated this a little bit over here. As you can see, you got a parent PID namespace. You can create a child namespace. And this particular area becomes an isolated file system that can be run independently of the underlying parent namespace. And then you've got, you can separate out user IDs and host IDs between hosts and containers. Okay. Now, when we talk about, we also touched upon network isolation. So as I've given a little illustration over here, you got a small process namespace running and then another namespace running. You create different network interfaces for each of these, which will then bridge to the main network interface of your parent PID. And then all this is possible, and what adds on to this namespace is the ch root, that is the change root facility feature that allows a process to change its root file system from the underlying root file system of the operating system. So that you can create these isolated environments within a larger environment. I'll take a little pause over here to understand if you've got any questions. Okay, I'll take silence as no. Right. So why do we need to look at security in containers? So what are the risks and how they can be addressed? So we looked at having different namespaces, which is isolated environment within a larger environment. Then we have got processes running over here. So when you have a process running in one isolated namespace, and if it tries to actually crosstalk or do an inter-process communication with another process in another isolated namespace, then, and you don't want it to do it. So this is one of the risks that can surface for containers. The unauthorized inter-process communication between one container and another container. Then also, if containers are not configured properly, then your network interface can have unauthorized inbound and outbound network communication, with the outside world. So that's another risk. Then you can have root ID. The user namespace within this container trying to take on the privileges of the root of operating system, which you don't want to do. So that's another risk. Then you can have denial of service via one of these containers actually consuming excessive resources with from the operating system. So these are some of the risks. I'm sure there are a lot of other risks, but in the interest of time, we'll just look at a few of them. And then how do we address these risks? So as we talked about, there are namespaces. So to address denial of service via excessive consumption of resources, we have C groups. So what they do is they isolate and manage resources from an operating system perspective. So if you put a cap on the C group, then this container will not be able to consume all the underlying operating system resources for itself. Then there are other features that are technologies. Not technologies, there are other means that are available. Like there is App Armor. What App Armor does is it restricts the permissions of a file to certain permissions. And if a file tries to execute more than what is allocated to it, then it will not allow it to do so. Let's take an example. For example, in this file system, in this process 8, if it has a particular file, like maybe I don't know, maybe it's trying to run a web server, but if the web server is also trying to write to the root directory of the operating system, and if you have App Armor installed on this container, then it will prevent that particular file from writing to the root directory of the operating system. So SE Linux is also based on restricting permissions and accesses but it is a lot more restrictive than App Armor. So SecOp also does similar activities. Right. So before we start looking at the whole container stack, I'll take a pause over here and ask if you have any questions on what we discussed so far.
So, Shruti, just to let you know, there might be a small lag, a couple of seconds, normally 10 to 30, between what you say and what comes to the audience via the YouTube stream. Okay. However, they can always write questions in the YouTube chat, and we can forward it to you as they come. So, okay. Don't necessarily run through the slides, but do not stop all the time to ask questions. We will forward the questions as they come. Okay.
Okay, fair enough then.
No
so
worries.
Let me continue.
Yeah.
Thank you. Okay. So we talked about what container is, what's container, how is it created in an operating system. Now, if you were to go and then create a container on an operating system, each and every time you want to run a service, it would be time consuming for you. So you would not be able to do it in a manner that is profitable, so to speak. So containers are actually written down as an image. It contains all the file systems and all the dependencies that are required to run a container. Now, this is static in the sense that an image is created and stored in a repository. So when you want to run this particular image, then you have a supporting technology which will pull the image from your repository, put it onto the operating system, and then run it, call the APIs, underlying APIs and all that. That's why we start off with saying that, a container image is something that is at rest. And then when a container is, when the image has to be instantiated, then it becomes a container, and that's what is run on the operating system. Now, we talked about, a person, a single person, it's being challenging for a single person to create a container and run it all the time. So who does the heavy lifting? Um, we also talked about container images being stored in a repository. So we've got something called a container runtimes and then a container software. The purpose of having these container runtimes is it fetches the image, or rather, if you give an image to the runtime, it unpacks the required files and metadata and then hands it off to the kernel. Then it also makes an API call to the kernel to make sure that a namespace is created, isolation happens in terms of C groups, in terms of PID, in terms of user IDs and all that. And then it handles all the input and prepares a container mount point. So this is what a container runtime does. Now, we got images on in a repository. We have a container runtime, which if given a repository, an image, it will put it onto an operating system and run it. But you need some automated way to pull images from the registry and then give it to the container runtime so that the container runtime can go ahead, instantiate it on the operating system. So for that, you've got orchestration tools. Typically, though there might be overlapping functionalities, but typically orchestration tool pulls images from registry and then schedules workload within a cluster. So then we talked about all these things, but then why is security assurance for containers essential? When we talk about secure, which I referred to earlier, when we talk about security of containers, it's not just the applications that are running in containers, but it is the whole stack. It's the underlying hardware, the host operating system, the container software or the container runtime, and then the containers themselves. And why do we need to look at the security of these? Because we need to make sure that the containers are isolated, they are configured properly, the underlying container software or the container runtime doesn't have any vulnerabilities, and then it is patched or any other security features, controls are taken care of. Similarly, with the host operating system as well, you need to make sure that it is secure, it is hardened, it has a secure configuration. You don't have any user doesn't have excessive privileges on the host operating system. So that's why you need to make sure that you need to factor in the host operating system. And then, of course, there is the applications themselves that are running in containers. For example, if you run a web server in a container, Apache HTTPD, and then it has, say, a vulnerability, then it could potentially affect the whole stack. So when you talk about security of containers, it's the whole stack and not just one or two layers. Now, some of the threats, we talked about some of the threats, but this is a different way of putting the threats. That is, you have lateral privilege escalation, you have exploitation of lack of secure configurations, exploitation of vulnerabilities in the container runtime software, and host exploitation of vulnerabilities on host operating systems. Let's start off and look at what it means, to secure each of these layers. Let's start with operating system layer. Now, operating system have vulnerabilities. They are applications like any other applications, right? And then they have got to be secured. For example, you've got to make sure that there is no, you have hardened the operating system. There are no unrequired services or protocols running on the system. Then they are patched properly, and you also make sure that the the access control is managed on the operating system, etc. So to make it easier, there are certain specific operating systems that are called thin OSs or stripped down OSs. Typically, the examples include CoreOS container that's provided by Linux. Then there is Bottlerocket provided by AWS. So these are meant specifically to run containers so that you don't have to worry about whether any unwanted service is running on your operating system or whether they are patched properly or not. So these, it's recommended that you use the stripped down OSs. But if you don't have stripped down OSs, then what do? Then you make sure that your operating system is hardened, patched, etc., etc. And on top of that, you also make sure that you do not mix containerized and non-containerized workloads on the same host instance. For example, you may be running a container to accept user input, and you may have just say some JSP files on it. And then you have another container which actually takes these inputs and then processes the input data. But if you install a web server along with these containers, then you're not being very secure because you are mixing different types of workloads, and any any vulnerability that is in the web server that you have installed along with the containers might actually affect your containers. And similarly, your containers, any vulnerability with the JSP files or the way you are processing your input might actually percolate down and affect your web server as well. So it's a good practice to make sure that you separate out the containerized and non-containerized workloads. And then you also need to implement and enforce network segmentation. So there are different types of network configurations that are available, like bridge, host, and none. Bridge actually allows you to just see it allows a container to see what's available in that host environment. And then host is when you configure the containers to run in host configuration, then there's no separation between the host and the container. So effectively, if you're running a web server on port 80 on your container, then the same web server is visible on port 80 on the operating system. So that's not really a very secure way to do it. Then none is when the container is isolated and it stays within itself. It depends on if your use case requires that, you can use it. Usually people use bridge just so that they can manipulate and control what kind of traffic goes in and out and what goes to the host operating system. Then the second layer is container software, securing the container software / runtime. So similar to operating system, you've got runtime vulnerabilities as well in terms of missing patches or rogue containers. Also, some containers trying to write onto operating systems or getting ingress and egress traffic from containers. The examples of container software runtime are runC, Docker, AWS Fargate, Amazon ECS. So what kind of controls, security controls, do we implement for runtime to keep it secure? Need to make sure that your container software is up to date. That is, it is patched and it's the recommended vendor version. You also need to make sure that you have implemented a role-based access control to restrict key access to key components. You don't want anybody and everybody accessing your container runtime, and also any component in the ecosystem accessing your runtime. So it's good to have role-based access control. Also, to make sure that you address the security at runtime, it's good to document what your container processes. So if a particular container processes input data and you have consolidated all of that on one host, it's good to document that and know about it. And monitor all the writes that a container makes to an operating system. Monitor your traffic, network traffic, and then explicitly define the permissions required by the container and its components. This prevents lateral privilege escalation and also horizontal privilege escalation. Then the next layer is storage and retrieval. So what do I mean by storage and retrieval? On one of the previous slides, we talked about container images. You need a place to store those container images. And also you need a tool that can retrieve those images from wherever you have stored them, pass it to the runtime, container runtime, which will then instantiate it on the operating system. So to make sure that your storage and retrieval registry or repository is secure, make sure that you have implemented a proper access control. Access is everything, right? If I can get root access on all the systems, I can do a lot of things, some of which may not be nice. So make sure that you have implemented a proper access control. You make sure that your connection to registries is over TLS. It is secure. You don't want anybody doing a man-in-the-middle attack to inject something malicious in your images while it's in transport mode. And then you scan your images when you're storing them. So you know that nothing malicious has gone into your images. And you're not really creating a rogue container with that. And then group your containers of relative sensitivity. For example, when you are actually deploying containers onto your host machines, if you need a set of, say, 10 containers that will process personally identifiable information, then deploy it on one host. Don't mix it up with the containers that process, say, cardholder data or that processes just plain input data. Because that way you can apply relevant security controls to that host to make sure that your containers are secure or the workload that your container is processing is secure. So, and then also make sure that in the repository, when a container is no longer needed, you offload it or make sure that it is marked as deleted. And in the runtime environment as well, when a container has reached its lifetime, then delete it off the host operating system. Don't maintain it on your host operating system. And then the next layer is creation, testing, and accreditation of your images. So here we briefly touched upon, how to store images securely, how to manage access control, how to group your nodes, your containers, with the same level of exposure or data as per your data classification. But how do you actually create and make sure that you got secure images? So it's good practice to employ CI/CD pipeline, because then your whole deployment or your whole ecosystem gets fairly automated. I'm not saying it'll get fully automated, but fairly automated, to make sure that when you create your image, you are actually scanning it to make sure that you have not embedded any credentials in it. You have made sure that your file system is not accessing any other files outside of its container without a valid business reason, or it is not trying to gain any kind of a root privileges on the underlying host system. So to make sure that you have created your image properly, you can scan it. If it's in a CI/CD pipeline, you can scan it in the beginning itself. Then when you are actually processing it through the pipeline, you can monitor and make sure that there is no invalidation of the configuration settings that you have already implemented. And then you can also sign your images with cryptographic signatures to make sure that they are trusted. So when an orchestration tool pulls out your image from the repository and passes it on to runtime for eventual instantiation, it will know that it's a trusted image by validating the cryptographic signature. And then how about the containers themselves? So I'm sure you've all heard about immutable infrastructure. So it's always a good practice to use immutable images to instantiate containers. So what you do is you create an image, instantiate it, don't change it. If any vulnerabilities are identified with any of your components, then just delete that container and then create a fresh immutable image which can be instantiated. So you're not really patching it and running it, because each time you create an immutable image, you are actually making sure that it has all the latest patches, it has all the latest security controls, and you don't have to worry about it once it's running. The way to do it is you can't keep immutable images. The lifespan, let me put it this way, the lifespan of an immutable image is not very long. It's typically between 2 and 4 weeks. So that at a given point in time, any vulnerability that is found with any of the stuff that you're running in your container is no longer than 4 weeks. It's a very short span, but it's a good way to do it because you're addressing your vulnerability, your security concerns in a fast manner, and you're not mixing up different things. Probably one component is patched, the other one is not patched. You don't have to worry about it if you have an immutable image creation mechanism. And also, when you are running your when you are creating your image, container image, you enforce isolation and segmentation by application, service, and workload, which we briefly touched upon and under orchestration and under runtime. And then monitor your process or file system for any suspicious activities. For example, a particular there may be you may be running a container which has an application and has an inbound network connection. So this particular application in the container may have a vulnerability, and then that once if that vulnerability is exploited, it allows you to run remote code execution. So in spite of having an immutable image and making sure that you have isolated your container and all that, that particular vulnerability could get exploited and in a manner that the application or the malicious actor tries to write to the host operating system. So if you are actually monitoring your files and processes for any kind of suspicious activities, then you would identify that. I'll just give a small example over here, which I have found very effective. In a thin OS and in a stripped down OS, ideally there should be no no modification of your files, because it just has what a container runtime requires. So if you actually see, and then it's always good to implement file integrity monitoring on an operating system. So in such a scenario, on a thin OS, on a stripped down OS, if you see a lot of output from your file integrity monitoring, it shows that something is not going right. That means there is some kind of a anomalous activity that is going on. That's one way to look at identify a malicious activity in a quick manner, rather than looking at a lot of false positives and trying to identify which one is the real one in this, which is the real event. Is this a real event or not? That kind of a thing. So then moving on, quarantine any compromised containers. Don't leave them in. Make sure that they are either removed or they are quarantined. If your in case you're not using immutable images, then you ensure that an automated software update or a replace process is implemented, typically in a short time span, like 2 to 4 weeks, not longer than that. And then limit access to the containers, limit access of the containers to the underlying file system, underlying operating systems, file system and kernel. It's not a good practice to allow containers to write to the operating system file system. Okay? And then on general, regularly automate your security scans to make sure that your whole operating system is being scanned and monitored for any malicious activity. So in summary, securing containers is not the same as security of containers. To ensure that you've got a secure container ecosystem, you need to secure the whole stack. That is the operating system, container runtime, image repositories, orchestration tools, and the applications running in the containers. That's all I have got. So if you have any questions, I'm more than happy to take them.
So, hi, Shruti.
I'm
Thank
sorry.
you very much for this presentation. If you want, I can remove your come on, Alex, function again. I can remove your share screen from the stream. If you want to open maybe your camera, which will make the discussion more natural, and I can start putting Mark and hi, Mark.
Back again.
Yes, and Dan, back to the stream. I actually have one question, which might not be very surprising, but I mean, I don't know what exactly the audience knows about virtualization and this kind of stuff. So I wonder if you would explain briefly, the differentiation between containers, virtual machines, process isolation, sandboxing, I mean, application sandboxing, and if you had to recommend uses of these in comparison to each other.
Okay, sure. So when we talk about virtualization, it can happen at hardware level or at operating system layer. So when you do it at a hardware layer, you got a hypervisor, and then you run virtual operating systems on them, so that the underlying hardware resources are shared. Because you're only sharing the hardware resources, you can install different operating systems like Windows, Linux, etc., on the same bare metal server or the hypervisor. This, when we contrast this with application containerization or containers, then you are actually virtualizing the operating system. So you are running your processes on top of an operating system, and all those processes share the same resources from the operating system, including your file system, your network, and the hardware resources and all that. So when containers are run on operating systems, they all share the same. You can't have different operating systems, but in a hardware virtualization, you can have different operating systems. That's one bit. Now, when we talk about sandboxing, that means we are actually creating a boundary around the application. You can create a boundary around an application or an application component, but that is to make sure that you don't have any unauthorized inter-process communication, or there is no component that is making any unwanted calls with either the underlying operating system or with the external world. So you're creating a boundary and you're restricting those calls. Have I answered your question, or? Does that make sense?
Yes, it does. So, I mean, if we wanted to get paranoid and stack things over the other, would you think that we should do something like that? So, isolate. Let's say that we are conducting malware analysis. Would you recommend us to use only one VM? Would you recommend us to use a container in a VM? What are your thoughts on that?
It really depends on your use case. So if I were actually doing it, I would use a operating system, hardware virtualization versus a container for malware analysis. But I know, speaking to some people, they prefer containers because they don't have to really, implement another operating system, because then they can run 2 or 3 containers and see how the malware behaves in a different environment in each of them. So, but I would, if my preference is virtualization, hardware virtualization for malware analysis.
Okay, thank you. Any other thoughts, guys?
Yeah, I've got a question for you, Shruti. You touched on lateral privilege escalation of containers. I just wondered if you might be able to expand on that, kind of explain it, because I didn't quite understand what that meant.
Sure. So when we talk about privilege escalation, there is vertical privilege escalation and horizontal privilege escalation. So when you talk about vertical privilege escalation, you gain on privileges. For example, I'm just a normal user, but then I try to add privileges and permissions to my ID and try to become an admin or a root on a system. In a lateral privilege escalation, you have certain privileges, but you have a user, you have an ID, but this ID will work on the same in, say, 10 servers, but you have access to only one server. When you gain access to the other 9 servers to which you are not authorized, that is lateral privilege escalation. So your permissions remain the same, but you have gathered access to more resources. So in the context of containers, when a container is, it's isolated, but it's not supposed to have any inter-process communication, but it does that. That means, it has gained lateral privilege escalation because it has gained access to another container.
Cool, excellent. So just thinking, we often say, when with containers, that you shouldn't run your container as root. You should run it as a low privileged user.
Yes.
So to avoid that lateral priv escalation, would it help if I ran each of my containers with a different UID, user ID?
Yes, absolutely. Because, actually using the namespace, you can ensure that the UID 0 on the root account on operating system is actually mapped to a non-privileged account in your container. So, and the vice versa also holds good. So you create a process, you've got a root account, which has all the privileges, which is UID 0 in that container, but you make sure that it's within that namespace, so it doesn't go outside of it. That then there's no vertical privilege escalation.
Yeah. So that would be the host breakout.
Yes.
Yes. Cool.
It would be the host breakout, and also if it tries to gain lateral privilege escalation and then gets to another container and gains UID 0 privileges, so it would be a combination of both horizontal and vertical privilege escalation. So it would be a root on that container as well. So that's the multiple container breakout.
Cool. Thank you.
No worries.
Let me check on the YouTube chat once more, but I don't think there is a new. Yeah, haven't seen anything.
Well, I can go with another one if you like. So,
sure. I love questions.
Are we going to give a virtual pizza to the person that has the best and the most questions?
That's going to be me, it's right.
Yes.
Terrible. Can't hold it to me. Everyone else, quick, find a question before I ask it. Because I've written notes down. So someone's mentioned on the chat about Trivy being a useful tool for container image scanning. But when you've got a container runtime environment, what kind of tools are there out there that we could use to monitor that, or even to sort of use it as an assessment tool, even to see whether running instances are vulnerable to something?
Yes. So you got tools like StackRox and Twistlock, Aqua, which do varying level of monitoring on containers. So they're not one size fit all. You need to make sure what your environment is about, what you really want to monitor, and then select the tool accordingly. So some of the examples are Aqua and Twistlock and StackRox. I think Twistlock was bought over by Palo Alto, if I'm not wrong.
Yeah, that rings a bell, actually.
Oh, yeah, it's clear.
Someone's writing me across. So I'm going to read some of these. So many times.
Mark, I can actually show it on the screen. Shruti, can you see it, however?
Yes, I do.
Okay.
I do it. Yes, it says as many people are becoming more reliant of these providers to secure. Actually, Fargate, AWS Fargate.
Sorry, Shruti, I realized, I had a lag on so this is the start, actually. I think this is the start. So now it should make sense.
Okay, perfect. So cloud providers do their own services, which abstract. Cluster security to be lost. Well, it's a choice. So there are services like Amazon EC2 or Kubernetes, where of course you don't do the underlying OS operating system host security, but okay, no, let me take a step back. So Amazon EC2 is more like you're building up the whole stack. So if you want to do that, there is always that choice. And on the other extreme end, you've got Amazon Fargate, wherein you just write your code like you would write Lambda functions. You've got the whole thing as a service as well. So it's a choice that you make. I don't think it's causing any kind of a cluster security to be, the skills to be lost, because after all, who work in Amazon and provide Fargate services, they have got to know about cluster security, operating system security, about thin OSs. So it's just that, consumers are being, given that freedom not to do it. So if you see what I mean, so you're separating the consumers from the actual providers. So if I do the whole stack myself, I am my provider and I'm my consumer. So I need to know the whole stack, the operating system, the clusters, security skills, and everything. But if I consume, as a consumer, if I opt for Amazon Fargate, then that's being isolated from me. But Amazon still has got to take care of that whole stack. So it's not lost. It's just a choice that you make where you want it to be applied, and if you want to apply it.
Another one from Ryan, similar one. So
I think this answer is a Twistlock or Aqua or StackRox. I'm sure there are a lot of other frame services, but these three, are at the top of my head.
Let me check again. So far, nothing else, at least from what I see on the chat.
Actually, when you're doing your containers, you may want to have a good look at your CI/CD pipeline, because a lot of things can be taken care over there. Especially, when you create a container and look at the vulnerabilities that might get induced into it, especially the applications that you're running in it, because it starts right from there. So if you're running a vulnerable web server in your container, so no matter how secure your container is, it's still going to remain vulnerable because you've got a vulnerable component running in it. So the same vice versa is also true. You might have the latest version of a web server, but if you have not secured your container in terms of your namespace, then it will still have a breakout. So, it works both ways.
Excellent. Any other questions? Let's see if the lag of 30 seconds, I can't see anything else so far.
Something I should know, probably. Do we in OWASP have any kind of like a checklist or something for
I think, yeah, for containers they have.
Yeah, so we could have a look at the OWASP website as well and find more resources there. Yeah.
Yes. Or we could even do a project to write our own, guidelines for the whole stack. That's another option.
Shall we wait for a couple more seconds or minutes and then maybe stop the stream?
Yeah.
I mean, I hope, Shruti, next time that you present for OWASP, it's for in a venue here in Bournemouth where we can see you.
Yes, I would really like that. Thank you.
This is very convenient though, because you didn't have to commute. But we miss the social interactions.
Indeed, and also a beer.
Yeah.
Right. One more time, I'm checking. I don't see any comments or chats. So thank you very much once more, Shruti.
Thank you.
And I will remove you now from the stream. So if anyone wants to ask Shruti, did you have on your slides your email, Shruti?
I could share my OWASP email ID. It's just my first name dot last name at owasp.org.
Okay. Right. And then I should say thank you very much once more and good night.
Thank you. It was my pleasure. Thank you. Have a good evening. Bye then. Thank you.
Bye. Right. Anything before we go, guys?
No, I think it was a good talk, and we'll have another one at some point in the future. Not anything planned yet.
Okay. Right. So thank you all. Have a nice. It's actually not night. I think it's later. I might be so tired. So guys, thank you very much for joining us today on this virtual meeting. I hope to see you soon in person, and not only for the pizzas and the drinks. So good night.
Good night, all. Thank you for joining.
Cheers. Thanks for coming.